It displaces 18,750 tons of seawater, a mass that defies the visual logic of buoyancy. This is not merely a vessel. It is a submerged industrial city built from HY-80 high-yield steel and enriched uranium. The Ohio-class ballistic missile submarine represents the apex of American naval engineering and the ultimate guarantor of global ruin. At 560 feet, it rivals the Washington Monument, yet it operates in an environment hostile to human biology. The paradox of this machine is absolute. It is the largest submarine ever fielded by the West, built solely to disappear. It generates no wake, leaves no thermal scar on the surface, and operates beyond the reach of standard acoustic detection. This is a national strategic asset where the initial $2 billion price tag is irrelevant compared to its geopolitical weight. After decades of modernization, the true value of an Ohio hull is not monetary. It is the currency of existential threat. We are analyzing the transition from the pressure hull's geometry to the acoustic void that surrounds it. This analysis moves from the S-8G nuclear reactor to the lethal physics of the Trident 2D5 missile system. But ultimately, the lethality of the Ohio class relies on the psychological endurance of the crew within the pressure vessel. The Ohio is legendary not because it launches weapons, but because its silent presence ensures those weapons remain in their silos. To understand why this invisible Leviathan dictates the behavior of superpowers, we must dissect its anatomy piece by piece. Part 1. The Titan's genesis and the unforgiving physics of acoustic stealth in the deep ocean environment. The global theater views the Ohio not as a ship, but as a mobile exclusion zone of sovereign power. To allies, it is a nuclear umbrella. To adversaries like Beijing and Moscow, it is an unsolvable variable. Russian naval doctrine treats the Ohio patrol zones as areas of denial, viewing them with a mixture of respect and operational fear. To grasp the kinetic potential here, you must visualize the sheer scale of the displacement involved. Imagine the footprint of a Super Bowl stadium, then fill that volume with the density of a nuclear reactor. Laid across a playing field, the hull extends well past the end zones, a seamless monolith of hydrodynamic steel. In terms of pure mass, an Ohio submarine equates to 45 fully loaded Boeing 747 aircraft sinking in formation. Visualize 45 jumbo jets, fueled and passenger-heavy, merging into a single entity designed to prowl the crushing depths. This is a mobile fortress that carries the destructive yield of an entire naval battle group on its back. In the domain of undersea warfare, detection is the binary state between survival and immediate destruction. The hunter who detects first dictates the engagement envelope, deciding whether to track, signal, or kill. Consequently, the strategic submarine's primary directive is not velocity, but the ability to remain an acoustic black hole. This capability secures second strike, the guarantee that a nation can retaliate even after absorbing a devastating nuclear first blow. It is a fist kept in the dark, ensuring that no adversary perceives a window of opportunity for a capitation strike. During the Cold War, the Soviet Union countered this threat by creating bastions, heavily defended maritime fortresses. These bastions in the Barents and Okhotsk seas were layered with surface ships and aircraft to shield their own ballistic submarines. The Soviet strategy was defensive geography. The American strategy was offensive invisibility across the open global ocean. In the 1970s, as Soviet acoustics improved, the U.S. Navy's 41 for Freedom Fleet began to lose its stealth advantage. Age is the enemy of silence. Older reduction gears whine, and hull fatigue creates micro-vibrations detectable by modern sonar arrays. As passive sonar sensitivity increased, what was once background noise became a classifiable signature to enemy hydrophones. The United States required a generational leap, a platform designed under the ruthless standards of Admiral Hyman G. Rickover. Rickover did not tolerate engineering ambiguity. He demanded a reactor plant that was acoustically invisible and mechanically immortal. The requirements were contradictory: carry more missiles, stay submerged longer, yet generate less noise than the ambient ocean. From these impossible metrics, 18 Ohio-class hulls were forged, shifting the balance of power back to the United States. The design begins with the teardrop hull form, optimized not for surface aesthetics, but for laminar flow underwater. Hydrodynamics at depth is about managing turbulence. Turbulent water flow creates noise that radiates outward like a beacon. To silence a machine of this magnitude, engineers had to rethink the properties of the steel itself. The pressure hull is fabricated from HY80 steel, an alloy capable of withstanding yield pressures of 80,000 pounds per square inch. This material allows the boat to operate at classified depths, likely exceeding 800 feet, where pressure is relentless. At test depth, the ocean squeezes the hull from all vectors, compressing the steel diameter by several inches. The structure must be elastic enough to shrink under this crushing load without buckling or suffering catastrophic fracture. Ohio lives in this zone of high stress tolerance, a metal bubble suspended in a crushing, high-pressure liquid void. The exterior skin is clad in anechoic tiles, a rubberized synthetic compound designed to absorb incoming active sonar energy. These tiles function like stealth coating on an aircraft, minimizing the acoustic return ping to an enemy destroyer. More importantly, they dampen internal machinery noise, preventing the vibrations of the turbo generators from escaping into the water. But tiles are insufficient if the internal machinery is hard-mounted to the hull, turning the steel into a loudspeaker. To mitigate this, the Ohio class utilizes a design philosophy known as active vibration, isolation, or rafting. Massive turbo generators and propulsion turbines are not bolted to the hull. They sit on independent steel rafts. These rafts are suspended from the pressure hull by rubberized mounting systems that act as acoustic shock absorbers. The kinetic energy of the machinery is trapped within the raft, decoupled from the steel skin of the submarine. This engineering ensures that the vibration dies in the air gap, never translating into a sonar signature in the water. But internal silence is useless if the propulsion system tears the water apart at the stern. The enemy of stealth is cavitation, the formation of vacuum bubbles on the trailing edge of a propeller blade. When these bubbles collapse under water pressure, they snap shut with the violence of a gunshot. To a passive sonar operator, cavitation is not a noise. It is a distinct, rhythmic fingerprint that identifies the vessel. The Ohio's 7-bladed skewback propeller is a classified piece of geometry designed to slice water without tearing it. It operates at a low rotational velocity, pushing massive displacement while keeping local pressure above the vaporization point. The objective is not absolute silence, which is physically impossible in a fluid medium. The objective is acoustic camouflage, blending into the ambient noise floor of the living ocean. A competent strategic submarine sounds like rain on the surface, or the tectonic shifting of the seabed. It hides behind the snapping of shrimp and the low-frequency calls of whales, becoming a shadow in the soundscape. Powering this stealth ecosystem is the S-8G nuclear reactor, a pressurized water system of immense density. The S-8G does not breathe. It requires no intake of oxygen and emits no exhaust to the surface. It circulates water under extreme pressure to transfer heat, generating steam that drives the turbines and the boat. This creates a thermodynamic loop that allows the submarine to operate at high speeds indefinitely. The limiting factor of an Ohio patrol is never fuel. The reactor core is designed to run for decades. The only limit is the physiological and psychological endurance of the human crew and the quantity of food on board. This machine is a closed-loop biosphere, independent of the Earth's atmosphere. Oxygen is not imported. It is manufactured through electrolysis, splitting seawater molecules into breathable air. Carbon dioxide is chemically scrubbed from the atmosphere using amine systems, keeping the air breathable for months. Fresh water is distilled from the ocean, purified, and cycled through the crew and the cooling systems. The Ohio class is not just a weapon. It is an engineered planetoid capable of sustaining life in a vacuum. It patrols for 90-day cycles, submerged in a state of suspended animation, waiting for a command that may never come. But when we analyze the purpose of this endurance, the narrative shifts from survival to destruction. We move from the reactor compartment to the missile deck, the Sherwood forest of vertical launch tubes. Here, the engineering changes from defensive stealth to offensive annihilation. Behind the sail sits a flat, expansive deck housing nearly 24 independent silos. Each hatch covers a Trident 2D5 ballistic missile, the most reliable delivery system in nuclear history. The Trident 2D5 is not a simple rocket. It is a 3-stage, solid-fuel vehicle of the apocalypse. It weighs 130,000 pounds and stands 44 feet tall inside the pressure hull. Upon launch, the missile is not ignited inside the submarine, which would incinerate the boat. Instead, it is ejected by a steam gas generator, punching through the water surface before the first stage ignites. This phase change from underwater projectile to aerospace vehicle happens in seconds. The missile accelerates upward, exiting the atmosphere to deploy its payload in the vacuum of space. This is the domain of celestial mechanics, where drag is 0 and velocity reaches Mach 24. The guidance system uses a star sighting aid, locking onto celestial bodies to correct its trajectory with mathematical perfection. This ensures that a warhead launched from an underwater platform can strike a hardened silo on another continent. The accuracy is measured in meters, a circle of error probability that makes the Trident a counterforce weapon. It effectively renders enemy silos obsolete, as they cannot withstand a direct hit of this precision. Originally, the Ohio carried 24 of these missiles. New START treaty obligations reduced this to 20 active tubes. Do not mistake this reduction for weakness. A single Ohio boat still carries more firepower than all bombs dropped in World War II. Each missile can carry multiple independent re-entry vehicles, or MIRVs. One missile splits into up to 8 separate warheads, each targeting a different city or military installation. A single submarine can theoretically prosecute 160 distinct targets in under 30 minutes. This is the Steel Rain, a saturation attack designed to overwhelm any existing missile defense architecture. 20 tubes transform this vessel from a ship into a planetary siege engine, hiding in plain sight. The lethal architecture of the Trident system is defined by its warhead configuration, specifically the W-76 and W-88 variants. The W-88 is a heavy, high-yield thermonuclear device designed specifically for hard target kill capability against reinforced silos. It enters the atmosphere inside a carbon-carbon composite cone that ablates under the extreme heat of re-entry. Physics dictates that at Mach 24, the air in front of the warhead turns into plasma, blocking all radio signals. The warhead must autonomously trigger its detonation sequence, often utilizing an air burst to maximize overpressure damage on the ground. This ecosystem is currently undergoing the D5 LE Life Extension Program, updating electronics to ensure credibility through the 2040s. However, the Ohio class has evolved beyond purely nuclear deterrence into a premier conventional strike platform. The 4 oldest hulls, Ohio, Michigan, Florida, and Georgia, were stripped of their nuclear status and reborn as SSGNs. These are the 4 horsemen of the fleet, guided missile submarines that trade apocalypse for precision kinetic effects. Engineers removed the Trident infrastructure and installed multiple all-up-round canisters to house Tomahawk cruise missiles. Where one nuclear missile once sat, 7 Tomahawk land attack cruise missiles now wait in a honeycomb cluster. This conversion allows a single SSGN to deploy 154 Tomahawks, a volume of fire previously impossible. A Tomahawk does not fly a ballistic arc. It hugs the terrain, navigating via GPS and distinct visual landmarks. It flies subsonic, below enemy radar horizons, capable of loitering over a target area before delivering a precision strike. When an SSGN surfaces off a coastline, it brings more conventional firepower than an entire carrier strike group's air wing. This capability changes the political calculus. It offers the president a campaign in a box without nuclear fallout. But the SSGN modification added another layer of utility, a covert staging base for special operations forces. 2 of the 24 missile tubes were permanently converted into lockout chambers for Navy SEALs. These chambers allow combat swimmers to exit the submarine while it remains submerged and pressurized at shallow depths. The boat can also host the dry deck shelter, a hangar welded to the hull for launching swimmer delivery vehicles. This transforms the submarine from a missile silo into a clandestine mothership for direct action missions. Teams can infiltrate hostile coastlines, gather intelligence, or sabotage infrastructure, then vanish back into the hull. Whether carrying nuclear fire or silent professionals, the effectiveness of the Ohio class ultimately relies on human software. We now shift focus to the silent service, the 155 sailors living inside the pressure vessel. The most complex system on board is not the reactor control drive, but the psychological state of the crew. A deployment on an Ohio submarine is a study in sensory deprivation and rigid, unbroken routine. Once the hatches are dogged shut, the sun is gone, replaced by the artificial hum of fluorescent lighting. There is no day or night. Time is measured only by the 6-hour watch rotation and the drill schedule. The crew operates in an environment where a single valve turned the wrong way can sink the boat. Consequently, the training standard is unforgiving. Every sailor must memorize the ship's systems beyond their own specialty. This is the submarine warfare insignia qualification process, forcing a cook to understand nuclear propulsion casualty procedures. Until a sailor earns their dolphins, they are considered a non-useful body. a liability to the ship's survival. The isolation is total. The submarine does not transmit, because transmission equals detection. Family emergencies, births, and deaths on the surface are often withheld from the crew until the patrol ends. This familygram silence is the price of national security, a burden carried silently by every man on board. To maintain this tempo without breaking the human component, the Navy employs the blue and gold crew concept. 2 complete crews rotate on a single hull, while the blue crew is on patrol. The gold crew trains on land. When the boat returns, they swap immediately, keeping the machine at sea for up to 70% of its life. Inside the boat, rank structure is rigid, but the shared danger creates a unique, informal cohesion. The halfway night celebration marks the midpoint of a patrol, a psychological vent to release accumulated stress. Food becomes the only variable in a static world. The Ohio class is famous for having the best galley in the fleet. Fresh baked bread and steak dinners are not luxuries. They are calculated morale tools to prevent psychological decay. But the primary stressor remains the drill, the constant rehearsal of the end of the world. The launch sequence is a choreographed ritual involving the commanding officer and the weapons officer. It requires the 2-man rule, physical keys, and authentication codes that no single person possesses. In the control room, the atmosphere during a battle station's drill is cold, quiet, and terrifyingly efficient. Orders are repeated verbatim. There is no shouting, only the swift execution of a checklist designed for apocalypse. The crew lives with the knowledge that if they do their job for real, there will be no home to return to. This is the psychological weight of deterrence. The readiness to execute an order you pray never comes. And as the Ohio class ages, the strain on both the steel and the sailors begins to reach a breaking point. Part 4. The race against entropy and the industrial choke point of the 21st century. A strategic deterrent is only valid if it is operationally available, but physics is a relentless adversary. An Ohio hull is a pressure vessel that undergoes a violent cycle of compression and release with every patrol. Over 40 years, this metal breathing accumulates microscopic fatigue in the high-yield steel frames. Metal fatigue is silent. It does not announce itself until a catastrophic structural failure occurs at crush depth. To prevent this, the Navy operates under SubSafe, a quality assurance program written in the blood of past disasters. Every weld, every valve, and every inch of the pressure boundary is subject to non-negotiable verification. But as the fleet ages, the maintenance required to meet these standards expands exponentially. Operational availability, the percentage of time a boat is ready for war, is being devoured by shipyard delays. We face a strategic paradox. The threat environment is peaking just as the legacy platform reaches its physical limit. The solution is the Columbia class, the largest and most advanced submarine ever conceived by American shipbuilders. But building Columbia is not a matter of writing a check. It is an exercise in industrial mobilization. It is often described as an engineering challenge superior to the Apollo program due to the density of complex systems. The missile tubes alone are precision structures that must withstand the launch shock of a 60-ton projectile. The reactor core is a life-of-ship design, fueled to run for 42 years without a midlife refueling. This eliminates the 2-year dry dock period required for refueling, effectively adding patrol years to the boat's life. However, the supply chain for nuclear-grade components has atrophied since the end of the Cold War. The bottleneck is human capital, a severe shortage of master-level welders and nuclear engineers capable of this work. A delay in casting a single bow dome or certifying a steam generator ripples through the entire decade's schedule. If Ohio retires before Columbia is combat-ready, a deterrence gap opens in the national shield. This gap is the most dangerous window in geopolitics, a period where the correlation of forces becomes ambiguous. Columbia brings a revolutionary leap in stealth technology, the electric drive propulsion system. The Ohio relies on reduction gears to transfer turbine power to the shaft, a mechanical connection that creates noise. Columbia eliminates this direct link, using the reactor to generate electricity that powers quiet electric motors. This decouples the sound source from the water, pushing the acoustic signature below the threshold of the ocean itself. It is a ghost ship by design, built to survive in an era of seabed sensors and drone swarms. But technology means nothing if the ship is not in the water. The United States is currently forcing the Ohio class to run years past its original design life. This is a calculated risk, trading hull fatigue for strategic continuity, while the industrial base attempts to catch up. The adversary is watching this transition, looking for cracks in the schedule, looking for a moment of weakness. In 2026, the ocean is becoming transparent. AI-driven signal processing is stripping away the cover of the deep. The price of invisibility is rising, and the margin for error has vanished. The Navy must balance the maintenance of the old guard with the acceleration of the new breed. Every decision regarding shipyard prioritization is a strategic wager with global consequences. Because in the domain of nuclear strategy, there is no second place, and there is no retry. A failure of the deterrent is not a tactical defeat. It is the end of the nation-state as a functioning entity. The Ohio class has held the line for half a century, a silent sentinel that never blinked. Now, it must hold that line just long enough for the Columbia to take the watch. This is not a story about machines. It is a story about the will to maintain the peace through the threat of absolute ruin. The missiles are there so they never have to fly. The submarine is there so the enemy knows the cost of aggression is infinite. As long as the silent service remains undetected, the equilibrium of the world holds. But if the silence is broken, the world breaks with it. This has been an analysis of the single most lethal machine ever built by human hands. It operates in the dark, so you can live in the light. Stay critical, stay informed, and understand the machinery that underpins your reality. This is Future War Tech. Subscribe for the next deep dive into the hardware of geopolitics. Until then, the watch continues.